Okay, so let's go over, you said 38, right? Andrew, you said 38? Okay. Okay, so if I take a look at 38, if I take a look at all three of these, all right, for a relation to be a function, we can't have any x values repeating. It says use the vertical line test to determine whether each graph is a function or not a function, all right? A vertical line means that if I was to draw a vertical line through any part of this graph, are there any 2 points on this graph that line up vertically? So Andrew, if I was to draw a line through any, like if I look at any of these grid lines on my graph, do any of these grid lines cross our graph more than once? On this, do any of these grid lines, any of these vertical lines, do any of them cross the graph of this line? Does any of them cross that graph more than once? Where? You're looking at this graph. If I was to draw a vertical line anywhere along this line, do any of these vertical lines cross the graph twice? No. That means there are no x values. There's no points that have the same x value. If I compare that to 39, if I draw a vertical line through any part of this graph, do we have 2 places or 2 points that are on the same vertical line, or does it cross this graph any more than once? Yes. This vertical line crosses the graph here twice. This vertical line crosses the graph here twice. If a vertical line crosses a graph more than once, that means that we have 2 points that line up vertically, which means we have 2 points that have the same x value. If 2 points have the same x value, it's not a function. So here, our vertical lines do cross the graph. At least one of them crosses the graph more than once. That means that there are 2 points that have the same x value. This is not a function. 38, we have every vertical line we draw only crosses that red line once. So we have no points on that line or that function that line up vertically. So this is a function. Are you cool with that? Okay. So then if I move to number 40, while this is, thank you, while this is still a curve, I still don't have any vertical lines that cross this curve more than once. So this curve does represent a function. Does that help you? Awesome. Sit up. What else can I do for you guys? Okay, get your notes out. Nick, quickly go. I'm not telling you what time it is.
No,
You've
no,
got to
like
look at what passed.
I can't tell if it's 11 or 12. It's like,
What?
is it 11? I can't like tell if it's like on the left side or the right side of the 11.
Well, it can't be 12 because it would be having to decide between 10 and 11. So where's the minute hand? Is the minute hand after 12 or before 12?
Oh, it's after.
So that means that the hour hand has to be after 11.
So it's 12 or...
It's 11.
Oh, 11.
Isn't the minute hand between 11 and 12?
No.
Isn't it right on 11?
Yeah.
Then it's 11.
Alright, thank you.
You're welcome. So I have 127 is today. All right, we are still doing chapter 5, section 2. So 5.2 continued. And we're talking about function rules. Talking about function rules. All right, let's kind of review where we've been so far. We started, so this is a review. we started talking about things called relations. Relations are a relationship between two sets of data. It's a relationship between two sets of data. All right. We can, the data is written as coordinate pairs. All right. We can see them as tables of data, and we can see them as graphs of the data. So these are the different forms we can see a relation. So those are different forms that we can see a relation. One's tables of the data, one is a graph of the data. Okay. Now, we talk about functions. Functions are special types of relations. Just like squares are special types of rectangles, they have a very specific characteristic of a square of a rectangle that makes it a square. All right, a square is a rectangle with all the same sides or the same length. All right, functions are very special types of relations. And what makes them so special are no domain values repeat. Right? And if you remember what domain is, domain are your x values. We usually use x and y, but they're also your independent info when we talk about actual information. That's your domain. So that's a little bit of a review from Friday. So now what we're going to do is we're just going to start dealing with functions. Who needs to see what's up there? Hey Nick, can you write your name so I can see that? This isn't like a signature on a form.
Yeah.
Because if something happens in that bathroom, I need to know that you were in there. Thank you. I appreciate that. All right, so there are three ways to see functions or to represent functions. There are three ways. We've already talked about two of them because they are relations. So one is a table. The second one is a graph. And the third one is an equation. All right, we're going to be taking a look today at equations, is what we're going to be starting with. Who needs to see what's up there? Okay. So let's talk about equations, but there's another phrase that we use in this section for equations. Equations are really a function rule. So equations are really function rules. It's a mathematical rule. So rather than explaining, I multiply every x by 5 and then add 3. Rather than explaining that, we write it as an equation. All right, so equation, function, rule, those two are synonymous with each other. All right, An example of an equation or function rule is y is equal to 3x plus 1. That would be a function rule or an equation. How many of you guys remember Schoolhouse Rock? Like those Schoolhouse Rock videos for learning? Yeah? Okay. So I want you to pretend that this is a Schoolhouse Rock, all right, in thinking of this. So what we're going to make is we're going to make something called a function machine. Okay, so if we take a look at this little function machine, I know you guys are really jealous of my artistic skills. Don't be too jealous though. So here is my function machine. Inside the machine is our function rule. So this is y equals 2x plus 3. So there's my function rule. So inside the machine is our function rule. What we put into the machine, these are called inputs. Those are our x values, or our domain values, or our independent information. So I've just given you another term for domain. They're called inputs, because we're going to put x values into our function rule, and we're going to get out our outputs. And those are our y values, or our range values, or our dependent info. So we put in values into our domain, or our inputs. We have outputs, which are our y values. What do we get when we put x in? Yes? These, what do you mean? It could be any, it's anything. Like this is just an example of a function rule, and this is another example that I'm just simply using. Function rules are just equations. It could be any equation. It could be any equation. It could be exponential equations. Y is equal to 3x squared plus 2x plus 1. That's a function rule as well. It could be exponential. Y equals 2 times 3 to the third power. That's or to the x power, that's an exponential function. So function rules are just equations with x and y in them. Okay. All right, so what I want us to do is I want us to evaluate this function, making a table. All right, so I want to evaluate the function rule, which just means equation, y equals 2x plus 3. So while you obviously aren't going to draw this machine again, now you've got a picture in your mind of what inputs are and what outputs are. Inputs are the numbers you're putting in for your x value or your independent information. Your outputs are the numbers you're getting out once we do all that math, or your y. All right, so I want you to evaluate this equation. So I want you to evaluate when x equals 2 and 3. I'm just going to do these two. All right, so let's do it when x equals 2. So I have y equals, and I'm just going to input that 2 value in for our x. God bless you. And then we're going to do our math. So I'm going to make a table of values over here with our inputs and our outputs. Now you don't have to do a table unless they ask you to, but I'm going to have us do this in table form. Evaluate the function rule, put in table form. So when I put an x in for my input, what do I get for my output? When I put my 2 in for my x value, my input, what did I get for my output, Matthew? 7. My output is 7. Remember, my inputs are my x value or the independent. My outputs are the y value or the dependent. Let's do the second one. So when I put 3 in for my input, what do I get for my output? Kaylee? 9. You guys cool with this? Yes? Okay. Now, if they don't have you make a table, you don't have to. But I do have to know which input, like I did here. I wrote my input x equals 2, and then I did the math for it, and I see what my y is. So I do need you being organized, because if you're finding more than one, if you're using more than one input to get your output, you have to say organized so I know which goes with which. Does that make sense to you guys? Okay, so let's do a couple more here. All right, so I want you to evaluate okay, there's something else I want to talk to you guys about. Let's go back to this. Can you guys see, if I take a look at this, can you guys see for us to know what I evaluated, Ashton, sit up. This is my x value, here's my y value. If I had to do a whole bunch of these, to stay organized, you need to tell me what x is so I know what x goes with which y. How many of you guys understand that? Okay. There's something called function notation. It's very similar in the idea as probability. But function notation is a special notation process. Let's say just special notation that allows you to see both the input and the output partner. The way that we write this is f and then in parentheses x. Or I could write G and then parentheses X. It doesn't matter what letters on the outside. The X is the variable inside the equation. So this right here says f of x. The function with x in it, f of x. This one here says g of x. And it just takes the place of the y. So instead of saying y equals, we're saying f of x equals. So when we have something like f of x, this is just the same thing as y. It takes the place of the y. So if I was evaluating when x equals 2, I would have f of 2 is equal to 2 times 2 plus 3. So I just substitute into the function notation what my input value is that I'm evaluating the equation for. Sam, you're writing this down. Okay. So when I get done, I have f of 2 equals 7. All right, so I want you guys, the next one, we're going to use function notation, okay? Who needs to see what's up there? So your book will kind of go back and forth between using y equals or using like g of x equals or h of x equals, all right? So I want you guys to evaluate f of a. This time I didn't use x. But what you're going to notice is this variable is the variable inside the equation. So f of a equals negative 3a plus 5. So in this function notation, f of a is equal to negative 3a plus 5. And if you notice that a is the variable in the equation, it is our inputs. So that variable inside the equation is whatever the variable is at our inputs. And I want you to evaluate for the domain negative 3, 1, and 4. So I want you all to do this, please. You don't have to make a table, but I want you to evaluate that equation for those domain values. Remember, your domain are your inputs. Come on, you're doing this. Stop designing stuff and get going. So you're all doing this, please. Expectation is everybody's opening up their notebook. They're starting at the first page, and you're working your way page by page by page with their notes on them. Work. You finish today's, tomorrow's on the next page. You finish tomorrow, the next is on the next page. This is ridiculous. This is ridiculous. I want you going back, and I want you fixing this. I want all of this done properly. I will not allow this for your notes. I'm not. I'm not allowing this for your notes. I want a brand new notebook. And you can tell your mom and dad why I'm making you get a brand new notebook. And I want you starting your notes properly. So by tomorrow, by the end of this week, I want a brand new notebook. And your math homework better be the same thing. That it's sequentially, each page is a new day. Not randomly placed in your notebook. Do you understand? Alright, so what I should see is something like this. F of negative 3 equals. And then I see you substituting that value of negative 3 in for the variable. So f of negative 3 is equal to, well, negative 3 times negative 3 is a positive 9 plus 5. So f of negative 3 is equal to 14. So you can see how nice and easy it is to see what the input was and what its output partner is. That's what I should see for each of these. So what did you guys get for f of 1? What did you guys get for f of 1? Jacob? Positive 2. All right, so I have f of 4. What did you guys get for f of 4? Peter? So I have negative 3 times 4 is 12 plus 5, right? Okay, so just switch it. You need to fix that. So what would f of 4 be, Serena? Positive 7 or negative 7? Negative 12 plus a positive 5. Negative 7. Questions? I want you finishing doing all of this. I don't know what you're doing. Put this away. I don't want to see that. I don't want to see any more doodling. I want you doing your work. All right. So now someone tell me, what's your range? What's your range? Remember, your range are your outputs. It's the values that you're getting after you put your inputs in and you do all the math. Our domain was -3, 1, and 4. Those were the numbers that we were putting in. Okay? So someone tell me, in this, what are my range values? Remember, your range are your outputs. Kaylee? 14.2 and -7. We usually do them in order of least to greatest, but at this point, I don't care. All right, we will change that. I'm going to write or -7, 2, and 14. In your book, it's always going to be least to greatest. Questions? All right, let me give you guys another one to do. All right, so I want you to find the range of the following function. Using the domain values -2, 0, and 5. All right, and my function is f of x is equal to f of t is equal to t squared plus 1. So I want you to find the range values, which means you're doing all the math. Find the range values of the following function. F of t is equal to t squared plus 1, using the domain values -2, 0, and 5. So go ahead and do this, please. Evaluating that function rule, or that equation. Function rule and equation are exactly the same thing. So evaluate that function rule. F of t is equal to t squared plus 1 when you have your domain values of -2, 0, and 5. Remember, your domain values are the variable inside that equation, so it's the t. Make sure you put that -2 in parentheses, because that -2 is the entire base. Serena, what's -2 squared? What's negative 2 squared? Positive 4 or negative 4? So it's positive 4 plus 1. So what's f of negative 2 then? 5. All right. Somebody tell me, what's f of 0? Ashton? So I have, what's 0 squared? 0. So what's f of 0? 1. All right, someone tell me what to do for f of 5. Go ahead. +25 + 1. So what's f of 5? 26. So if I wrote our range, remember we put it in brackets, or those braces, in order of least to greatest. Somebody tell me what my range is. Go ahead, Troy. 1, 5, and 26. Nick.
I have a question, but it's not about the this number of numbers, like the exponent. So if we have really exact numbers, like just like if you say the numbers really like 2, 3, 4, couldn't you just add 1 to each one after you doesn't matter?
Well, that's why the function rule is what it is there is a pattern, because that's what equations are patterns, but I need to see the math. So I do want to see math. Okay? I'm glad you can see a pattern, but I do want to see the math. Okay. Yes? Shh. I would like for you to get in the habit of being able to write them in list form in brackets. Okay, either way is fine, but you will see them a lot just in brackets. Okay. All right, you guys can go.